All right, hello students. A couple of these substitution problems from the problem set were a little tricky for people. And one thing I want to encourage you is to try other substitution techniques before you resort to trig substitution. And this is something that I was working with a few of you on. If you look at problem number 1 here, it looks vaguely trig-ish, and you can set up a triangle with it. There's actually an easier substitution that you can use on this one. If you just set u equal to x minus 1, then your du is equal to dx. And the nice thing about that is you can solve the top equation for u plus 1 equals x, and then you can rewrite the entire integral as u plus 1 over the square root of u du, separating that into u divided by the square root of u is square root of u, and 1 divided by square root of u is u to the negative 1/2. And so then without drawing the triangle and going through all of that trig substitution, you can just add 1 and divide by the new power, etc., etc. So when I look at this problem here, my first reaction was to try to do it as a trig substitution, but the clue that might be helpful here is that it's not an x squared minus 1. And so you didn't quite have the Pythagorean feel to it. You can make it work, and I'll see if I can make a trig substitution work in a separate video. But sometimes if there's a linear term in the denominator, just setting u to be that linear term in the denominator and then solving for x allows you to express the numerator linearly, and then you can separate it out like I did on this one. I would use the very same strategy on problem 2, setting u equal to 2 minus x and then solving for x to be 2 minus u, and that way you can expand it all out and square it and everything like that. The one that I would actually use a trig substitution on would be problem 4, because that denominator there looks like Pythagorean theorem. Okay. So for problem 4, I would do a trig substitution on it. For problem 1 and 2, it's not a trig substitution, it's just a u substitution. For problem 3, it's also just a u substitution, setting u equal to 1 plus cosine x. And then you'll be able to take its derivative and it'll cancel out the numerator. Okay. So in another video, I'll show a couple of the trig sub examples here, but I just wanted to mention that a couple of these that look sort of like trig sub problems can be done using just u substitution.